Hello everyone, welcome to Learn Overflow. In this video, we'll discuss another LeetCode problem, that is, where will the ball fall? So this is a medium level problem and we'll understand exactly how we can solve this question and what is a pretty much trick behind solving a question like this. Before moving on, if you haven't subscribed to this channel, make sure to subscribe to Learn Overflow for regular LeetCode videos like this. The question says we were given a 2D grid of size m cross n. So that's a grid given to us, which represents a box. You have n ball, like n cross n is like the box we have given to us, okay? And we have n balls. So n ball is like the number of columns in the grid, right? It's like that there are like n balls given to us. The box is open at the top and the bottom. So there's the box is open at the top, okay, and also at the bottom. So that's given to us. Uh, Further, it says each cell in the box has a diagonal board spanning two corners of the cell that can redirect the ball to the right or the left. So this diagonal board like this, you see, this diagonal board like this, and each of these are spanning through the diagonals, and it can redirect the ball to the left or the right depending on which side the diagonal is. Fine. A board that reflects the ball to the right spans the top left corner to the top right corner. That is, it reflects the board to the right, spans top left to top right. Okay. Sorry for the drawing, but yeah, from top left, bottom right corner, and is represented by in the grid as one. So whenever there's a rightward movement, like top left to bottom right, then it is represented as one, and the reverse is there. A board that redirects the ball from the left, like to the left, spans top right corner to the bottom left corner. So from top right to the bottom left corner is represented as -1. So this is represented as -1. So that's pretty much how the board is defined to us. Now, further, we need to understand, like, we drop one ball at the top of each of the column. For each of the column, you dropped one ball, and like each of the ball gets stuck in the box or fall out at the bottom. So somehow the balls will get stuck inside or will fall out. So a ball gets stuck if it hits a V-shaped pattern between two boards. Like if there's like a pattern like this, okay, it's the boards are coming and the two boards are closing up to each other. So the ball gets stuck over there, and or if it redirects the ball to either of the one. Say one of the ball like this. Okay, so the ball was probably coming from here. So one of the ball is redirected to this. Okay, look at this. So whatever ball gets stuck over here, it gets stuck with the wall and this board. Okay, so that's the whole idea they're mentioning to us. Okay, further, what's our target is? What do we need to return? We need to return an array, like the answer of size n, where answer survives the column that the ball fall out at the bottom. So finally, we have to see, like, where will a ball fall out, whether it will even fall out or not. Okay, like after we have dropped the ball from the ith column of the top. Okay, now we need to return -1 if the ball gets stuck in between. Fine, that's pretty much the understanding. Let's quickly see what the example like given to us. Example says, see, the example is like a grid given to us, right? A grid, you can see 1 -1, 1 -1, such things are there. So that's how for each row wise the grid given to us, and there you see that the ball 0 starts from the first column and end up like 0th column and end up at the first column, right? So that's why the for the 0th question the answer is 1, like it end up in the first column. Okay, for rest of the ball, you see that none of them actually end up like getting out of the box or out of the grid. So here we return -1 for all of them. Fine. Now, that's pretty much what we get to understand from this. Now, let's understand how we should like solve this, or how we should see whether a ball is getting out of the grid or not. Okay, so to find a like to think of this, what we need to see is like see. Like we need to track each of the ball one by one and then move to the next ball. Fine. So here we will be tracking each of the ball one by one. Now see how we are supposed to do that. Uh, we started with the first grid. Fine, we started off with the first grid, or started off with the first ball. Now in the first ball, what this will do, it will start from the 0th place and we find it's the right one, like it's a 1 is there, right? So this grid value is 1, obviously, because it's showing us to right. Now we need to check whether the ball will move only if the next row, or sorry, the next column in that row is having the same value. Okay, next column in the row is what? The next column in our row is also 1. Okay, so if both of the value in the same row is same, then we know that the ball will be moving to the next row. Fine. The ball is moving to the next row. Now we'll move to the next row, and for this particular column, whichever we are at right now, for this particular column, we'll see whatever the current column value, uh, then we need to see whether this next column values have also having the same. Now, you mean what the next? What do I mean by next again and again? So I mean is, if the current column value is 1, then we will look to the right whether the next column value is also having same value, that is 1. Okay. In case it is not having a same value, then we know that that particular ball cannot move forward. Right? But in case it is having the same value on the right, because it has 1 in this, our current column had 1, we need to see what's the next column, like on the rightmost next right column have. Is it, if it's that also 1, then the ball will move forward. But if it's not 1, then the ball will get stuck. And also, if in case it was like this, it was like the right bound, like the left bound board was there with us in the grid, then we need to have checked for the left column. Okay, so it depends on which side is our current column, like the current grid value is showing us to. Fine, we'll check for that side position. Now, once we reach this side position, we need to check again. Like now we are in the third column, right? Now we'll check for the next row in the third column. The next row in the third column shows us to the leftward direction. Fine. So in that case, we will again come back. Like since it was showing us leftward direction, we'll come to the left and check whether the current column is also having a leftward direction or not. If it is not, then that's the end. But if it is, we'll move forward to the current column next row. Right? Next row is just moving down. That's the pretty much the way we are working with. Fine. Now here, like in the other example, you see like the first case. Wait, you see like the first case. I'm just taking. Let's take the example of the second ball. In the second ball, you find that the first case, it is both are moving rightwards. Right. So we find the ball will move rightwards. Now we are in the column 3, or the say from 0 index. So column 2, we are at column 2 right now. Now I find in the column 2, in the next row, what is there is like our current row is showing us the rightward path, but so we checked for the rightward value. So we find that okay, in the rightward path is the different value. It's not the same. So we find okay, we cannot move forward. So it's a 0th index. I mean that's a -1 will be there. So the ball cannot reach the end. Fine. Similarly, we need to check in case any of the ball is hitting the like if there's a condition like this, then we need to check if anyways it's going out of the boundary or not. Okay, anyways if it's going out of the boundary, such cases are there anywhere or not. Fine. So that's the stuff. So what's the main thing over here? I hope it's understandable. Like we are checking for the next thing. So what's the main thing? The main thing is like we drop the ball at the 0th row, right? At the 0th row and at index I. Fine. We drop the ball at 0, I, somewhere like at row 0, I, being the number of columns. Fine. Now we track the ball in the we track the ball in the I1 column. Fine. We need to track the ball in some I1 column. Remember? So how we're doing that? We're simply checking whether our we just want to check that if our ball needs to move from this I1 to some I2. So what basically we're doing? We are initializing this I1 as I5, and then we're checking if we are moving from I1 to some I2, depending on which side our current board directs to. If it's a +1, we are moving to the right side. If it's a -1, we are moving to the left side. Fine. So I2 will determine what's the current value on the grid. Fine. So we'll find out that if there's some if you want to move the ball from I1 to I2, then we need to have you need to have for sure that J of J I1, Okay, so what I mean by J is pointing to the current row. So in that row, I1 should be equal to JI2. Fine. That row I2. So if this is equal, like JI1 is equal to JI2, in that case, you can be sure that a ball will be rolling. Fine. So in that case, we'll change the change the row. Then we'll check for our current I2, that wherever we are we getting roll? Is our ball moving forward or not? Fine. So that's the pretty much idea. Now, if I just write this code, you will understand it much better. So let's quickly write this code. I hope you will understand it how it works. So here you see, this is like the code you have over here. Fine. Let's see what we did. We first of all took the M being the grid length and N being the column length. Fine, like a total number of columns. Now this is a resultant array. This is the one which we are supposed to return. Fine. Now we ran a loop for each of the column. So what it means is like we are tracking for each of the balls we have. Fine. So one by one we are tracking each of the balls, and whatever is resultant, we are storing it in our resultant array, like the result array. Fine. Now. First of all, we initialized I1 as I and then another variable I2 that we will be finding out. Fine. Whether we will be moving right or we will be moving left will be determined by our I2. Now, what we're checking, that now we are running a loop for each of the column. So, no, sorry, for each of the rows. So J is what representing our rows, right? Now we're checking for each of the rows. So what exactly we are doing? Remember, like usually if you follow any kind of pattern questions or those kind of questions where we follow patterns and all, so there we usually run the row loop, like the loop for our row being the outer loop, and the loop for our columns becomes our inner loop. But here we just twisted that part. We made the loop for our columns being the outer row, so that we can track each of the balls, and the loop for our row became the inner loop, so that we can see where our ball is getting stuck, or is it actually coming out of the box or the grid. Fine. So that's what we are doing. So this is the loop for our rows. Now, what we are finding out is the I2. I2 is like I2 is I1, that is a current column value, is which is initially I. So the current column value plus our grid of JI1. So wherever our grid, our current column value, and wherever our grid position is pointing to. If our grid position is 1, so that will be that will be increment in the column value, right? I2 will be greater than I1. So if in case the grid value is 1, in case the grid value is -1, that will make it decrement. So the column will be on the left side if I2 is like, if the grid value is -1, so that will move us to the left side, and if the grid value is +1, so that will move I2 on the right side. Fine. Like right side of I1. So I1 is the current one. So based on what's the current grid value, we'll see where our I2 will be. Is it on the left or is it on the right? Fine. There we find that. Now we're checking in case our I2 is going out of the box, like less than 0 or greater than equal to n, like if it's going out of the box, or in case our grid values of I1 and I2 in a current row I1 and I2, if those are not equal, then we are making I1 as -1, right? That means we couldn't find a solution, and we're breaking the solution. Okay, we're breaking this in our loop of rows, and we're storing that in our resultant array. Right? That means there's no way we can reach the endpoint, or we can come out of the other end of the box. Fine. But in case this is not true, that means if we find that the ball is moving, or that means that our current grid values are going forward as same, so we just make our current I2 value as I1. So we just changed our column. So for first we had a column 1, like column 0. Now we move to the column 1 because ball moved to the column 1, right? So that's what we did over here, and we keep on doing that. If we somewhere we end up, we store I1 in this. Like if we come out of the loop, like come out of the box, then also we store I1 in it. Fine. Now that's how this question works. Fine. That's how this question works pretty much. So if I just run this code, we'll understand it better. So here you can see like how it works. So let's quickly submit it, and you'll be able to see how it goes. It's not 17 ms. I bet it's not 17 ms. So that's it. uh, I don't know like how why it does like this, but it's more or less 2-3 ms. Okay, so previously when I tried, it was somewhere around 2 ms it came. Anyways, that's not a big deal. See, it just went down to 3 ms. Anyways, so this is like a basic concept. You can go ahead with it, fine. But there's something else you can also try out. You can try out a DFS to track the ball. Okay. Also, you can try the DFS, like a DSA. So you can say this is more or less a DFS kind of approach, but no, this is like more or less a iterative kind of approach. You are just going in and in and in. That's iterative kind of approach. This is not. I don't say this is DFS approach. This may look like DFS because for each of the ball you're tracking to the end, but this is an iterative approach. Fine. So then what can be other approaches? You can also try out our dynamic programming approach where you'll store where's the previously a ball was. If the ball was stuck somewhere, that's -1. The ball isn't stuck somewhere, we'll keep storing the value. Like if that there will go row by row. Fine. So that's more or less the approach. So this another like if you want to see a much faster like a 0 ms solution, so you need to modify this code in some other way. Like you may modify this code a bit more. So nothing like your complexity is not going to reduce, but you may modify it based on adding a function or moving some of the parts in the function, and then modify it based on some tricks. Okay, so small tricks. So that might reduce this code. So if I could end up finding out a solution like that, so then I'll post it in the in the solution over there. Okay, so you can find that in our description. You can find this code also in the description, and there's a link always every day. There's a link for this code, whatever is there. So I hope I can make you understand how you can solve a question like this. So thank you all for watching this video. If you have any doubts or any queries, make sure to put them in the comments below. I'll be happy to help you out in the comments as well. So thank you for watching this video. Hope to see you soon in my next video as well. Thank you.